Okay, so we're now on to lesson 6, and this is integration with substitution but involving trig functions. But first I want you to pause this video and do the starter question by yourself. Okay, when you're ready, here are the answers. So pause the video and correct your working. So I want you to give yourself a mark out of 3 for this. Okay, now we're going to go on to the main lesson. So as I said at the start, this is called integration with substitution with trig. So let's take that as our heading in our notes to authors. Integration, substitution, with trig. Okay, and I've only got one example for you to do. It is quite a long example. So number 1, find, and we've got the integral sign between the limits of 0 and 3/4. And we've got a fraction, so it's x over the square root of 9 take away 4x squared dx. Using, and we're given the substitution, it's going to be x equals (3 over 2 sine u). Okay, so already this question is a little bit different because our substitution is in terms of x, and we're used to something that's like u equals, but don't let that confuse us. So let's move on to the answer. Okay, the same way that we always start any integration with substitution questions is we're going to see what we can sub out already. So we've got 2 x terms in here, and we know that x is 3 over 2 sine u. That's the first thing I'm going to swap out. Okay, so I'm just going to keep my integral sign here. I'm not putting the limits in right now because I'll need to change those eventually. So on the top, we've got 3 over 2 sine u, because that was just x on the top. And on your denominator, we've got the square root of 9 take away 4 times x squared. Now, if I know what x is, we can quite easily square this. So to square a fraction, you just square the top and square the bottom. So this is going to give, just open brackets here, it's going to give me 9 over 4. And if you square the sign, you just get sine squared u. Okay, so all I've done is change the x's for that amount. Right, what I'm going to do is draw my line, and then we're going to start doing all the working at the right hand side. So including dx and including our limits in here. Okay, we're going to start by differentiating this. So remember, we're differentiating x. So we're going to have dx, and it's with respect to u. So that's why it's dx over du, not the other way around in this case. Okay, so if you differentiate sine, that just goes to cos. So it's just going to give us 3 over 2 cos u. Now I want dx by itself because that's what I'm trying to swap out. So if I multiply both sides by du, that will give me dx by itself, and that's what I want. So 3 over 2 cos u. Okay, so straight away I can swap this dx out for all of that. Okay, so I'll try squeeze it in here. 3 over 2, oops, I should have a du there, shouldn't I? Cos u du. Now, you might think, why on earth are we doing this? This looks so much more confusing than that first line. Just trust me on this. Everything will eventually cancel off, and it will turn out to be a really nice integral. But it is going to get extremely messy before we get there. Trust me. Okay, so I've dealt with my dx. Now what I'm going to do is deal with the limits. Because right now the 0 and 3/4 there in terms of x, but remember we're changing all of our x's for u. So new limits. So let's deal with the lower limit first of all. This is when x equals 0. And I want to figure out what does u equal when x is 0. So all we're doing is we're changing the x for a 0 here. 3/2 sine u. And then just rearrange the formula to get u by itself. So the first thing I'm going to do is to divide by this fraction. Okay, so you could do a method line if you want and write down divide by 3/2. So 0 divided by that just gives you 0. 0 equals sine u, and obviously to get u by itself we just take the sine inverse of 0, which we know from the sine graph that sine of 0 is just 0, just at the start there. Okay, so our lower limit actually stays the same, which is 0. Okay, now let's deal with upper limit. So this is when x equals 3/4. We're going to do the same sort of thing here. So go back up to this substitution here. We are changing x for 3/4. So 3/4 equals 3/2 sine u. And then you can just use your calculator for this. We're trying to rearrange to get u by itself, so we're going to divide by 3/2. So if we type in 3/4 divided by 3/2, that's just going to give you half equals sine u. U equals sine inverse of a half. And then u is going to equal, so this could come up in paper 2, which is dead easy, type in your calculator, but it could also come up in paper 1. So you need to know your exact value of triangles for this. It's 1 to √3, and then we've got pi over 3, pi over 6. Okay, so I want a half here. So saw, Katoa, saw opposite over adjacent. Hypotenuse, sorry. So opposite over hypotenuse, it must be pi over 6. Okay, so your upper limit is pi over 6. Right, have a look at this. Right, it's so obvious that we are not ready for integration at all. Okay, this full thing can be tidied up, right? So let's take it step by step. It is going to get very messy, so please feel free to pause the video as you're working through this. Okay, so the first thing that we're going to do is to multiply out these brackets. Okay, so everything that's not in the yellow stays the exact same. We're just going to multiply these out, and then what you can see is that actually that 4 can cancel with that 4. So it just leaves you with minus 9 sine squared u. Okay, so everything else can stay the same right now. So integral between 0 and pi over 6. 3/2 sine u at the top over the square root of 9 take away 9 sine squared u, and it's all multiplied by 3/2 cos u du. Okay, so this looks a little bit nicer. Still not ready for integration right now. Okay, we're still going to focus on the bit under the square root sign. That's what we're focusing on. Okay, what we're going to do is start by pulling out 9 as a highest common factor here. So this should always work out where those both numbers are the same. That's all we're doing in the next part. So if I pull 9 out, it's just going to leave me with 1 take away sine squared u. You've still got your 3/2 cos u du at the side. Okay, so you might have said to yourself, like, why are we doing this? So the whole point of doing this is because now I've got 1 take away sine squared u here. Now, remember from National 5, it's one of our trig identities. I'm just going to extend this down. We're going back to the right-hand side, and I'll show you what happens. Okay, so we've seen this expression quite a lot. So it's sine squared plus cos squared equals 1. We've seen that before in quite a few examples. Now what I'm trying to swap out is 1 minus sine squared u. So what I'm going to do is subtract sine squared on both sides. So that's going to give me cos squared u equals 1 minus sine squared u. So that bit there on the right hand side is what we've got in this bracket. So I'm going to swap it out for cos squared u, and you'll see why I've done that in a wee second. So integral sign between 0 and pi over 6. 3 over 2 sine u, and it's now all over the square root of 9 cos squared u, still multiplied by 3 over 2 cos u du. Okay, so the whole point of doing that is because I can then work out the square root of this. You see, if I go back up a part, up here, because that's two separate terms in there, we're not able to just square root that and square root that. Can't do that. You need to have it just one singular term, which we've now made it as one singular term, so I can square root everything just in the winner. So that's the part we're going to do. So all we're focusing on is just what's in that root sign. Okay, so everything else can stay the same. Okay, so that denominator, we're just going to deal with the square root sign. So if you square root everything, it just gives you 3 cos u. So I've square rooted that and I've square rooted that. Times by 3 over 2 cos u du. Right, still not ready for integration. However, it is getting a lot nicer. Now, what you might be able to realise is that what you could do is you could extend this fraction line all the way along. Hold on. So I could extend that fraction line. It's a little bit squinty, but you know what I mean. So we can quite clearly see that I've got a cos u on the bottom and a cos u on the top. So they disappear. Okay, so it's just a case of dealing with these numbers, then we've got sine u by itself. So I'm just going to take the integral sign between the limits of 0 and pi over 6. Okay, so feel free to use your calculator here. This part here, if you take this into 3 over 2 over 3, that's going to give you 3 over 6. Yeah, 3 over 6 and a half. So what we're essentially doing is 3 over 2 divided by 3. I'll just put it over 1. So when you divide fractions, remember you flip the second and multiply. So I'm flipping that one. So if you cancel this off, or multiply the top 2, multiply the bottom 2, which is a half. Okay, so that's what that part gives you. So just get a half sine u times 3 over 2 du. Because remember the cos u cancelled off. Again, feel free to type this into a calculator. This is just how you do this without a calculator. Keep your integral signs there, 0 and pi over 6. What we're going to do is deal with the half times the 3 over 2. So multiply the top 2, multiply the bottom 2, gives you 3 quarters. Sine u du. Now, how nice is this integral compared to what we started with there? Right, feel free to pause this and rewind. We went from that stage all the way down just to 3 quarters sine u. Okay, so let's integrate this as normal. Okay, so if you integrate sine, that's going to take you to negative cos. So negative 3 quarters cos u. Pi over 6 and 0. So let's just start subbing in these limits here. Okay, so I've subbed in pi over 6. Take away. Please be careful with brackets and negative signs. So I would recommend like sub in your first limit, pi over 6, put all of that in brackets, and you're taking away everything else when you put in zeroness. So I would always separate this with brackets, just to keep the negative signs correct. Okay, so this could be paper 1, or it could be paper 2, who knows. Right, so we're just going to do this without a calculator. So I want to work out cost of pi over 6. I'm just going to scroll up till I can see that triangle that I had earlier. So cost of pi over 6, saw, ca, so it's adjacent over hypotenuse, so root 3 over 2. Okay, so I've still got my negative 3/4 times root 3 over 2 minus, I've got negative 3/4 times cos of 0. If you quickly just draw a cos graph, cos of 0 is just 1. Okay, so we could simplify this a little bit. So that's just going to give me negative 3 root 3 over 8 plus 3/4. Okay, so you might think, why is that plus? It's a double negative. Okay, so that's where I've got plus from. And then what you could do is you could just type that into your calculator. But I'm just going to do that wee approximately sign, because it's not an exact value. So I'll just type in right now. You can do the same, just double check it. Okay, so it's going to be approximately 0.1048 and so on. Okay, but you are going to get full marks at that stage. Okay, what I want to do is pause this, scroll back up, have a look at the full question, make sure you get your head around it, and there are quite a lot of questions today. Question 46 through to 53, and that's all on Google Classrooms for you to try, and just let me know if you're stuck with anything.